Hello, everyone, and welcome to today's webinar, Challenges of the New Euro 7 Legislation for Exhaust Measurements. My name is Jamie Disher. I'm from Hariba Europe Marketing, and before we start with the content, I would quickly like to introduce the software that we're using so that you know where you can reach out for support. So first of all, this webinar will be recorded, but don't worry, the only thing was visible in the recording is the presentation, the slides, of course, as well as video and audio of our presenters. The chat will not be visible, any participant information will not be visible, so there's nothing to worry about for you. Secondly, you have a chat function on the right-hand side where you can always reach out to me. In case there's any technical difficulties, I will try my best to support you from over here. And if you have any questions regarding the content, you can also ask them in the chat. However, we will not answer your questions during the webinar, but we will keep them with us for the Q&A part that we will do after the content presentation of our two presenters. So they will go through all their slides, and then afterwards I will ask your questions for you so that we can get some answers. And in case we run out of time or your question has not been answered sufficiently, you can always reach out to us via email, and we will make sure to answer you directly or forward the question to our in-house expert. And without further ado, I would like to hand over to our presenters for today, Irina Vanaka and Dr. Simone Eichmann.
Thank you very much, Jamie, for the introduction. Hello, everyone. Good morning, good evening, good afternoon, depending on where you are. So we are here today to talk about the challenges of the new Euro 7. So as you all know, the implementation date is soon approaching. I would like to talk about the Euro 7 today, and we're here to clarify what is being fixed, what is still evolving, so you can do your planning with confidence. So here is the agenda for today. So I'm going to be walking you through the legislation part, and then I'll hand over to my colleague Simone, who will introduce our laboratory and RDE solutions. So before we get into the actual contents, I'm going to talk about the Euro 7 overview. So before we get into the actual details of Euro 7, I'd like to quickly show you the big picture of how the EU legislation works. So EU 7 is shaped by these three main EU bodies, one of which is the European Commission, who's there to lead the whole process. It drafts the proposal and drives the work forward. Then the proposal is then discussed by the European Parliament and the Council, which is then they introduce their positions before the final regulation is agreed. So this slide is basically to show you, to set the scene, to understand who's involved and how the Euro 7 becomes a law. So this slide summarizes the Euro 7 decision timeline. The proposal was firstly issued by the Commission in 2022. Then that was discussed in the Council and the Parliament during 2023. Then later, 2023, that got passed through to a trilogue where the three main institutions has come together to one table to reach an agreement. Then finally, the text was published in the official journal on the 8th of May, 2024. 20 days later after that was the entry into force date on the 28th of May. So the key point here is that Euro 7 is now legally in force and the framework is fixed, which what I mean by that is that the direction and the overall timeline was set. So the details and the test procedure is going to be defined at a later stage, but at that point, the framework has been set. So what happened after that based on the official journal of 2024? I'm going to start off with the facts first to set the baseline and to move on to what that actually means in practice. So since the adoption of this official journal in 2024, the first set of milestone came in September 2025. And this first set of implementing regulation was the 2025 1706 and 2025 1707. They were published to cover the exhaust emissions, OB, FCM, and OBM, both including the emission limits and test procedure for light duty. And then the next phase, covering the battery durability, brake dust, tire abrasions, and low temperature ranges for BEV, is expected around the second quarter of 2026. Then the Euro 7 will then apply to new vehicle types from November 2026. And then a year later would be the new vehicles from 2027. For tires, it's coming out a later timing than that, starting to be applicable from 2028. So most of these actual requirements are developed under UN regulations, with the EU aligning them through their implementing acts. In the recent ACVES meetings, it was discussed that the mandatory compliant date would remain unchanged. However, there were discussion on clarifying this framework to allow testing and type approval to start as early as date specified in that official journal that is being worked on at the moment. So it doesn't change the mandatory dates that's illustrated here, but it also adds an option to when you can start preparing for, we can start tackling the Euro 7 earlier. Some of the OEMs may choose to do that. Others may prefer to wait, but both of the approaches are looking to be legally acceptable as of today. But of course, we'll have to see what the legislation says at the end of second quarter. So in terms of the context, what has already been decided and what's not, what is still under discussion, the black parts are the ones that's already fixed and are in the first set of implementing acts. So, and the blue parts are still under development. So for light duty, the brakes, tires, battery durability are still being discussed, called the second phase. For heavy duty, most of the contents are also going to be discussed. So I have borrowed this slide from the latest ACVES meeting, which shows you the Euro 7 light duty transposition activities from the UN regulations. So it basically maps the Euro 7 light duty requirements to the relevant UN ECE regulations where they're being implemented. So for light duty, many of the key elements are already progressing, and you can see which requirements are linked to which UN regulations, like the 154, 168, and 177. So these corresponding UN regulations were part of the package that got passed through to GRP in October, and now is expected to be voted at WP29 in March 2026, for that to be finally adopted and then to be referred to by Euro 7. So that was the overview of light duty so far, and the timeline of heavy duty currently looks like this. So the first set of implementing regulation will be adopted around the start of the light duty type approval testing, which is on November 2026. Then the second set will be coming in before the application date starts for heavy duty. That is in on the May 29th of May 2028. A year later, following on to a similar trend as light duty, will be the new vehicles, and then similarly, tire abrasion limit for C3 tires is expected to start around 2032. In terms of the requirements for heavy duty, what we know so far is that the heavy duty emission measurement system will be referred to UNR 49. But the new requirements, which I'm going to be talking about in the later slide, like the NMOG and N2O, will be also added to the UNR 49. And we expect this to be set around November 2026. Then they will move on to the second phase, but we'll discuss the details in the later slides or when we find out more about them. So that is it for the overview. I'm now going to be moving on to the light-duty vehicles requirements. Starting off with the Euro 7 exhaust emission limits. So as you can see, most of the numbers here are pretty much the same as in Euro 6E, except for the particulate number limit. So PN10 is going to be regulated instead of PN23. Additionally, under Euro 7, all of the gasoline vehicles must meet the PM and PN limit, which was previously only applicable for the direct injection positive ignition engines. So that's the laboratory. And then, so what is the situation is in the RDE? So I'm going to use the pointer here. So what it says in the regulation at the moment is to refer to Regulation 168. What it says in Regulation 168 is the NOx and the PN limit would look pretty much the same as Euro 6E. However, there are still not yet specified left for CO, THC, and THC plus NOx. As a result, we are seeing different interpretations from the Commission and some of the OEMs. The Commission's view is that it is not, if it says not yet specified, the limit will be defined at a later stage, while some of the OEMs interpret this not yet specified as meaning of there is no immediate obligation to measure. Our understanding from that is that NOx and the PN will be carried over from Euro 6C, whereas CO and THC is where further clarification is still expected. However, in parallel, we also understand that compared to when this light-duty RDE was firstly introduced in 2009-2010, today's vehicles are far more hybridized. So because of this, the Commission has raised concerns about potentially elevated levels of THC. So they have already started doing some background testing. So while the legislation is still evolving, our message here is that we highly recommend start building the actual evidences now. We'll of course keep you updated in the progress of how things develop, but we encourage that the OEM should be able to monitor their CO and THC data, so you can be ready to respond quickly once the limits and the compliance approach are finalized. So we have gone through the limits. Where can we find the test procedures? So at the moment, the real world driving emissions is currently written under Regulation 168. The laboratory testing is on 154, with the PN requirements currently written under the EU implementing regulations. However, the plan is to write this specification in the UN 168 and 154 so that the European regulations have to do, all they have to do is just going to be referring to the UN regulations. Then moving on to what that test system looked like in the laboratory. So this slide shows you the changes of the external emission test system for Euro 7. As you can see in the center, the PN10 devices should be added for Euro 7, but other items would remain pretty much similar to what we already had for Euro 6E. Simone, after that, we'll be discussing the technical details on this part. Also, what that also means for RDE is that we don't expect to see any changes regarding the gaseous emission limit, which is following the Regulation 168. But regarding to the PN limit, the new device to measure that is also required. Again, Simone will be talking about the details in her slides. So far, we have taken a look at the limit and the test procedure. So building on from that, we'd like to move on to the underlying principles. So this is hopefully this is going to be leading on to something in a good news. So as mentioned earlier, Euro 7 RDE method refers to Regulation 168 as the basis of the measurement. So under this Regulation 168, a list of standard analyzer is described. At the same time, Regulation 168 also allows the use of alternative analyzer, provided that they demonstrate equivalent or better performance and are approved by the testing authority. With that context, following the necessary work, I'm very pleased to share that Vehicle Certification Agency has approved our MexiCube as an alternative analyzer for the light-duty testing, light-duty certification testing, giving you an additional compliance option for RDE measurements. Okay, so that was the first part or first set of implementing regulation that's been released in September 2025. So there is another set of implementing regulation that's been released that talks about the OBM requirement. So OBM is a trip base. So start the propulsion system, you begin the OBM trip, switch it off, the trip ends. After that point, vehicle updates the monitoring status of NOx and also for PM. If either of them reaches the error status, the driver warning system has to alert to the driver. At the same end of trip moment, the vehicle also creates the data record. So that's going to be the distance-based NOx for that trip, plus the supporting parameter like the energy or fuel use or battery state of charge. And it generates a hash value so that the record can be later checked for integrity. Then this record will be made available in two ways. It is sent over the air when the connectivity is allowed, and it also must be accessible through the OBD port. So the message here is that Euro 7 adds the trip-by-trip evidence that the emission control can do stay healthy in real use, not just in the laboratory. So how is this OBM checked? During the in-service monitoring, in-service conformity, the NOx value reported by OBM is compared against the reference NOx measured by the approved emission system. So beyond this individual test, overall performance is also judged through the OBM dataset submitted for market surveillance to see how the system behaves in the real use. Importantly, the regulation also includes the value limit that the OBM NOx value must not be more than 30% below the measured test value. So technically, the requirement is driving more OBM development work, and at the moment we're seeing growing interest in the analyzers such as MexiCube to calibrate and validate the OBM system. This is also an area where Simone is also going to be talking to you about the details. Okay, so that covers the first phase of light duty. I'm going to move on to the second phase from here. One of the new requirements here is the brake particle emissions. So at this stage, only a particle mass emission has been defined. And then this is going to be reviewed over time, with the revised table expected to arrive around 2030 and then also in 2035. But in the final limit for light duty is fixed for all of the type of the vehicles as 3 milligrams per kilometer per vehicle. In terms of the test procedure, is based on UN GTR at the moment, but a transition to UNR 179 is expected. The regulation itself also defines the measurement method for all of the indicators, that's PM10, PM2.5, PM10, and TPN, which all requires to be reported. For the tire versions, at this stage, the limit table looks blank and they have not been finalized quite yet. In terms of the test method, that's also being currently looked under at the moment in the UN level. But yes, the intention is to use that UN regulation once that's been enforced. As for the timing, C1 tires, that's the passenger car vehicles, are applicable from 2028. C2 tires, the commercial vehicle tires, from 2030. C3, the heavy-duty vehicles from 2032. Moving on to the battery durability, Euro 7 introduces the new durability requirement. So at this stage, what has been decided is the durability requirement for light duty covering up to 8 years or 160 kilometers. In terms of the assessment method, the evaluation approach is defined under UN Global Technical Regulation 22, where again, they are discussing to transition that over to the UN regulations. Okay, that is it for the light duty requirements, and moving now on to the heavy duty vehicles. First of all, starting off with the exhaust emission limit. So this slide shows the left-hand side with the laboratory cycles, and the right-hand side is the on-road limits. So comparing that together with the Euro 6 limit, even with the familiar pollutants like the NOx, PM, and CO, there has been a significant reduction in the limit table. But Euro 7 also expand the scope to include the limit for particles, PN numbers down to 10 nanometers, and also add the NMOG, ammonia, NMOG, ammonia, methane, and nitrous oxide. Formaldehyde, on the other hand, the value is not yet given, but the Commission is currently under review to set whether to set a specific limit for formaldehyde, and that's going to be happening before the end of December 2027. One of the new components, as I've shown you in the previous slide, is the NMOG. There is a definition in the Euro 7 language, but the calculation formula is not finalized yet. However, there are two candidate formulas, one of which is to use the formula used by the is by the US EPA, and it uses the alcohol aldehyde values and that are sampled by the impinger or cartridge, and then measured by the gas chromatology. Another possible formula is the EU original one. This method uses the formaldehyde values and the values related to the fuel property. So the measuring principles, you may be looking at this slide thinking it's very different from light duty, but the main message we want to get across today is that QCLIR technology is a compliant method in the regulation, and we are doing the final work to make that 100%. So as mentioned earlier, emission measurement method will follow the UNR regulation 49 series, and now is the amended regulation to include this QCLIR technology has been voted in the WP 29 in November 2025. In this draft, QCLIR is included. However, there are some conditions for the alternative analyzers. For example, this has to be type examined by the Meteorological Institute. technical service or type approval authority, and it will also have to be compliant to CEN. And we are planning to have that ready by the end of this year. It's not in a topic today, but we also have the same text in the Regulation 96 for non-road, for those of you who are interested in non-road. So we also have that assessed and appraised for non-road as well by the end of this year. What that test system looks like in the test schematics, this is what it used to look like in Regulation 49, the current version. One of the examples of Euro 7 measurement would look like this, with the N2O measurement, formaldehyde, and SPN10 that are new components. For heavy-duty brakes, it is expected to have the limit set by the end of 2027, looking at how things go with also the light-duty as well. There was an interesting discussion that I'd like to talk to you about in the latest ACVES advisory group of vehicle emission standard discussions. The ACVES discussions highlighted there's a mismatch between the vehicle level limit and the aftermarket reality. What I mean by that is that they indicated that the brakes were typically replaced by axle. Rarely they wouldn't replace the front and rear at the same time. Whereas the Euro 7 limit currently defines the brake emission limit as a whole vehicle level. So it was discussed that this created a technical uncertainty to the aftermarket, including a significant increase in the brake family, high test burden, and wide variety of the original equipment front and rear emission ratio. So to address this, a proposal was discussed to ensure that any of the combinations of original equipment and aftermarket brake components would have to be still compliant with the vehicle level brake emission limits, but the details are still to be discussed in the upcoming meetings. It was also noted that similar principle may become relevant for this aftermarket component, such as the brake, the batteries. Also, although this will also have to be discussed, but that's also still an early discussion. Tire abrasion limit is the situation is still behind to light duty, whereas in the heavy duty is starting at around 2032. The technical details of the battery durability will also be defined later. So looking ahead to the new Euro 7 elements, the battery durability, brake emissions, and tire operations, I'm going to talk to you a little bit about our solutions. The evaluation method is actually coming very closely to being finalized for light duty, the UN regulations. For battery durability, the challenge is running repeated drive and charge cycles on the chassis dynamometer without consuming excessive engineering time. So this is where our automated robot could potentially help by running the battery consumption sequence consistency and efficiency. For the brake emissions, Horiba Germany already has a compliant test facility, so we can support you by doing some contract testing as well, if that would be useful. Tire abrasion is still under active development, and we are also involved in both of the regulatory drafting and in the testing activities. I won't go into the technical details today, but we are more than happy to support whatever need, whatever questions or requirements you've got, and we can cover that in the later discussions. So this will be my final slide for the day. To wrap up, for light duty, the first Euro 7 implementing package is already published. 2025-1706 for exhaust and evaporative emissions type approval, and 1706 for OBM and the data framework. Next package will cover the remaining new elements such as battery, brakes, and tires, expected around the second quarter of 2026. The legal start date is fixed for light duty on the November 29th, 2026, then to all of the new vehicles a year later. For heavy duty, the detailed implementing rules are still being developed. The base regulation requires the Commission to adopt these implementing acts by 29th of November 2026. Then it will be applicable for Euro 7 from the 29th of May 2028. So with that context, I'm going to hand over to Simone to share some practical insights on the technical side.
Yeah, thank you very much, Irina, for this really broad and deep overview on the new requirements of the upcoming Euro 7 regulation. In the next part, I will now talk about the solution HORIBA offers to support you to fulfill this requirement. Here on this table, I summarized a little bit the components which are regulated currently in the Euro 6e regulation for light duty and heavy duty, and compared it with the components which will be regulated in the Euro 7 also for light and heavy duty. When we compare this to regulation, what is new? Ammonia needs to be measured as mass. N2O was added. Basically, THC and non-methane hydrocarbons were replaced by NMOG and CH4, and as Rina said, formaldehyde will be reviewed again 2027, but will be needed anyhow for the calculation of NMOG, which means non-methane organic gases. When we look at the particle measurement, PN23 was replaced by PN10, so also smaller particles will need to be monitored. Okay, what are now our solution for that? Of course, you can measure the... Okay, what happened? Of course, you can measure the traditional components still with a MEXA1 analyzer, so CO, NOx, THC, CH4, you still can use your current installation, and also for particle mass, there are no changes you can use there, our MLT1. For the new regulated components like NH3, N2O, and formaldehyde, so when you look at the gases component, you have basically two options. We offer one is an FDR-based analyzer, the FTX1, and the other one is our QCL, so quantum cascade laser IR-based analyzers. In a few next slides, I will talk a little bit of the difference on the two technologies and also on the analyzers we offer for that. For particle measurements, we upgraded our SPCS1, our particle counter, to measure also smaller particles. I would like to go now a little bit in detail on the specifications on the analyzer, basically starting with a particle measurement. As I said, we have upgraded our SPS1 to measure also smaller particles, starting from a particle size of 10 nanometer. The measurement principle is still a condensation particle counter. We use a hot catalytic stripper for volatile particle removal with an efficiency of more than 99%. The counting efficiency is bigger than 90% for particle size up to 10 nanometer and higher. You can use the unit for ambient conditions of 5 to 30 degrees Celsius for standard configuration. If you use an additional cooling unit, you can even go up to 45 degrees Celsius, and for altitude use up to 200 meter. We have there also several options available. First, single unit, which is, we have of course still available a PN23 unit, but you can also have a single PN10 unit. It's also possible to upgrade current particle counter to PN10, so you don't have to buy complete new equipment. And in addition, we offer also here dual unit, which includes 2 particle counter, one for particle sizes from 10 nanometer and one for particle size for 23 nanometers. So both measurements are done simultaneously. We have different sample methods available. So a full flow tunnel for direct connection to CVS system, partial flow tunnel, and a direct measurement. Of course, we offer also several accessoires like a cooler unit already mentioned, a sample flow checker, a sample switch, and a linearity checking unit. Okay, now I would like to switch to the gases components, but before that, as I mentioned, I want to highlight a little bit the difference between both technologies and the pros and cons to help you to find the proper technology. In principle, QCLR and FTIR are based on the same physical background. So they both use the absorption of infrared light from the different gas components, and they also, and it's also the point that the wavelength of the absorbed light is unique for a certain species. That means that you can detect one component selective in a multi-component gas mixture. The amount of absorption is related to the concentration, so you can get also a concentration value out of that. Okay, what is now the difference between both technologies? This is shown here. I would like to start with the Fourier transformed infrared technology, FTIR. This technology is really able to detect a very broad wavelength range with a single setup, and this allows the detection of several molecules like you see here, like CO, N2O, CO2 with one single setup. But you also see that you have some overlap between the signals, which can be partly compensated, but typically you have to consider some residual interferences of 1 to 2 ppm, depending also on the component. In contrast to that, the QCL technology uses a very narrow band laser, and you look here only at a very narrow range of here, approximately 0.2 to 0.5 wave numbers, which allows you to detect this component with a very high sensitivity, so you can reach their very low detection limits and also minimize the interferences to less than 1 ppm. Okay, here are again a comparison of both technologies. In principle, the FTIR technology gives you a very high flexibility. You can easily adapt ranges afterwards. It's even possible to include new components afterwards without any hardware change. But on the other hand, although FTIR also offers a really good performance, you can just get better performance with a QCLR technology. You can reach the detection limits below 1 ppm, minimize the interferences. Also concerning robustness and maintenance, there's some improvement as you don't have this movable mirrors and you don't need utility gases. So it's really depending on your application, what you want to choose. Okay, now I would like to start to introduce you to our FTIR-based analyzer. That's our FTX1 family. We have there basically 3 options. One is the FTX1 CS, that's the compact version, which includes an FTIR with the possibility to measure simultaneously up to 28 components. We have the possibility to add up to 6 component sets for different fuels. Yeah, the analyzer operates at 5 Hertz and is compliant to the UNR 49 stage 5 and the GTR 15 regulation for ammonia. In addition, we have the FTX1RS available. That's our that also includes an oxygen and a THC measurement with an FID. This both analyzer, the FTX1CS and the FTX1RS, are for direct measurements. And in addition, we have the FTX1CL available. It's a diluted analyzer with compliance to EPA 1065 and 1066. Okay, now I would like to switch to our QCLIR-based analyzer. One unit is the MEXA1 XLNX, which measures beside NO, NO2, also N2O and formaldehyde. You can use it for raw as well as continuous diluted measurement. It has a resolution, time resolution of 10 Hertz and the detection limit of 0.2% for scale, which means between 0.2 and 0.4 ppm, depending on the component. It is developed for temperatures of 5 to 40 degrees Celsius and compliant to the EPA 1065 regulation, the UNR GTR 15 for ammonia, NO2 and N2O, and the UNR 49 regulation. Currently, we are ready for ammonia. For additional components, we need to wait till the regulation is finalized and we have this type approval, which is required. It's also compliant to Chinese regulation as well as the stage 5 for non-road mobile machineries. Okay, for formaldehyde, we have also a QCLR-based analyzer available. That's a 90-inch rack analyzer for implementation in MEXA1. We have ranges there of 20 and 100 ppm, also with a time resolution of 10 Hertz and with a detection limit of up to 0.2 ppm. Here you basically see measurements we conducted at JRC, where we compared our QCLR analyzer shown in blue with two FTIRs. One was our FTIR, the other was an FTIR from a competitor. And you really can see that even at this very low concentration range of 1 to 2 ppm, we have really very good agreement between the measurements. And yeah, also you can see that also good results are achieved with the FTIR. The QCLR just shows better, lower noise. Okay, this was actually a lab analyzer. Finally, before I switch to the RDE analyzer, I surely would like to talk about ammonia measurement. You know that ammonia will now be regulated not only as ppm but also on a mass base measurement, and this means that the ammonia measurement has to be aligned with the flow measurement, and we still hear some concerns from our customer, and therefore I would like to spend one slide also on this topic. So what is different from ammonia compared to other molecules? Ammonia is a molecule which has a very high polarity. This has different effects. One thing is that it tends to absorb at surfaces, especially if you don't have really polished surfaces, if you have some rough surfaces or you have some impurities, and this could lead to a really strong increase in the response time and overhanging effects. Another point is that due to this high polarity, it also has a high solubility in water, and therefore it can become very easy to ammonia losses if you have cold spots or also some droplets in the filter. And it also has a high reactivity, which could lead to reaction in the heated line, like the NOx reduction or also salt formation. These effects are really there, and therefore you have to take special care when you measure. But when you do that, you can minimize your effects tremendously. So here are some countermeasures. One thing is to minimize the length of the heated line and increase the flow if possible. Depends, of course, at the analyzer. Very important is also the choose of right filter and tube material. Yes, example, I have here a comparison of a measurement we did with a 6-meter heated line and a filter, and we have here in black shown our standard filter, which has a hydrophilic, so it means that water tends to absorb at the filter, and you get there a really long response time. But when we use a special filter, which we also recommend for ammonia measurement, where water absorption is avoided, you can really see that you can get very fast response times, which are not much higher than compared to other components. Here you see a comparison for ammonia measurements, which we performed once with a QCL-based analyzer, the Maxa 1 XLNX, and on the other side with an FTIR-based analyzer. So we have here different analyzers, different sample methods, and you really see that we can get really very good agreement between the analyzer. The peaks are really very good resolved, and you can get here very good measurement results. Okay, as I said, I will switch now to our solutions for RDE. Here I have again a summary of the components which are regulated for Euro 6E and Euro 7 for light duty as well as for heavy duty. Again, for light duty, there were not so much changes. And what's new for gaseous components, again, that we have to, that THC and non-methane hydrocarbons were replaced by NMOG and CH4, and ammonia and N2O have to be measured. Formaldehyde will be reviewed again, but need to be measured as part of NMOG. In addition, PN23 was replaced by PN10, so the challenges are similar compared to the laboratory measurements. Okay, what analyzers can you now use for light duty where there are not so much changes? You can, of course, still use the OBS1GS and the OBS1MA. Then we have already launched in 2021 our OBS1XL for ammonia and N2O measurement. That was more at this time or more planned for RDMA measurement to support you to prepare for the Euro 7 regulation, to have your to prepare your research and development. And now launched last year our MaxaCube, which offers the measurement of all components, including NH3 and N2O, and also shows compliance to current regulation, where we are now at still waiting for the regulation to be finalized. For the particle measurement, we have our PN10 unit, so we modified our current PN unit. Okay, I would like to start here again with the particle measurement. Also here, our new OBS1 particle measurement unit is based on laser scattering condensation particle counting. We also use a hot catalytic scripper. You can get here accuracies of ±10%. With drift of smaller than 100 particles in 4 hours, and we have several heated lines available. This PN unit can be used as standalone unit, but we can also include it in an OBS1 GS or in our MaxaCube. Both is possible. Then to the OBS1 XL unit, as I said, this is more designed for R&D application to prepare your engine and for the upcoming regulation. It allows measurement of ammonia up to 1,500 ppm and N2O from 1 to 1,000 ppm with a zero noise of 0.2% of full scale, so a few ppm. Here you see measurement in response time from ammonia. So even for ammonia, you can get really very fast response time of a few seconds. This was measured with a heated line of 4 meters. The accuracy of the system is shown here. So you see over the whole concentration range, you can get here accuracies of less than 1 ppm. Here are some measurements where we compared our OBS1 XL with the stationary system, the Maxa1 QLNX, which was at that time the predecessor of the Maxa1 XLNX. And when the other measurements were done at an engine dynamometer with a WLTC cycle. And yeah, when you look here at the measurement and compare the results from both units, you can see that there is really good agreement. Only very small deviations were found for NH3, but which did not have any impact on the final result. Okay, finally, I want to highlight our MaxaCube, our new RDE analyzer, which was launched last year, which allows the measurement basically of all regulated component in this in a very compact analyzer unit. It allows the measurement of CO2, NO2, N2O, ammonia, formaldehyde and CH4. All these components are will be measured with our unique island technology based on the QCLR technology. And we have also integrated in this unit also an FID analyzer for measurement of total hydrocarbons. Some specifications I want to highlight. So we have here temperature range from minus to plus 45 degrees Celsius and altitude of up to 300 meter. We have a time resolution of 10 Hertz, and the unit can be used for water concentration of up to 24%. Here you have some overview on the performance. So all specifications comply to the UNR 49 regulation as well as the UNR 168. As Irina's already mentioned, the UNR 49 will adapt the QCL technology, and for the light duty application, we have a VCA approval which shows us equivalency to the UNR 168 regulation. Okay, here finally some examples for the performance. Here we can see here are some results from detection limit where we compared the MaxaCube with our unique island technology with the OBS1, which is based on NDR technology for CO. And you can really see there that the detection limit is reduced by more than 1 order of magnitude. Here we have also some results from vibrational tests. Where we change the frequency over a very broad range, simulating typically conditions which occur in heavy train wagons. we reached here forces up to 2G, and what you do not see in the diagram that we also had here some peaks of 5G, and nevertheless we see no effect of the evaporation on the concentration results. In addition, we also did some measurements on a Belgian pathway where you also saw no effect. Here are some comparison from measurement of CO from the Mexacube compared with the OBS1. First, you see also at very low concentration, you have very good agreement. But when you look very exactly here on the results from Mexacube shown in black, you see that you have here just, slightly changes are just better resolved, and you have just also a better response time. Finally, the robustness against ambient temperatures, which is shown here in the example of NO. You see here that the pressure as well, the temperature as well as the altitude do not really affect the measurement. Okay, now I'm already on my final slide. I want to highlight again that we will provide you with solutions for the new Euro 7 regulation. We have solutions for stationary analyzers and analysis for RDE application, as we already mentioned. Nevertheless, we also give you the full support also for brake test, and we have also, of course, automation system to complete your application. Finally, I want to thank you all for your time. Thank you very much that you joined this webinar. We have some minutes left for a Q&A session. In addition, if you have any question, don't hesitate to contact us either directly, or if you do not have our contact, just get in touch with your respective salesperson. Yes, again, thank you very much for joining.
Thank you, Simone, and also thank you, Irina, for your presentation. We received some questions in the chat. I'm sure we will not be able to fit in all questions, but let's just get started. Does the OBS1 PM10 use butanol?
As far as I know, also I have to say I'm more related to the gases measurement. It's using propanol, but I will double check that with my experts here, and I think Jamie has the contact, so I will give you the information and in the next days. But yeah.
Yes, thank you, Simone. One question for the legislation part. When do you expect the necessary changes on the LDV Framework Directive 2018/858 to be adopted?
Thank you. Thank you so much for the question. So according to the latest discussions, as far as I understand, is that they're currently considering to do the amendment in early 2026, split into two sets of two sets. So the first set is linked to the very first package of light duty, which is expected around the spring of 2026. And then the second step is linked to the later part of the light duty, which is tentatively shown around the middle of 2026, so roughly around June, July time. But these are still presented as an assumption, so this is not a fixed legal date.
Thank you, Irina. And then also part of this question was, do you know if and when Euro 7 will be necessary for the UK?
Okay. For the UK, the honest answer is they are currently looking at how things do develop in Euro 7, but as far as I understand, they haven't given a specific date for when the Euro 7 will be applicable in the UK. However, there are already certain measures that they are doing to incorporate the direct UN regulations into the UK regulations. So, for example, UN 154 and 168 is already applicable in the UK. Sorry, hopefully that answers the question.
Thank you, Irina. One last question. Is there any special exhaust emissions device for alternative fuel, normally with high H2O concentration?
Yeah, as I said already, the MaxaCube is currently designed for up to 24%, and to our knowledge, typically hydrogen application as well as current research on ammonia engines do not have higher water contents. Typically, hydrogen engines operate at high lambda. And for the PN10 unit, we are currently also starting development to increase the water content, which we plan to have within 1 year.
All right, thank you, Simone. Thank you, Irina. Unfortunately, we're out of time, although there are still some questions left. So we will go through these questions and reach out to you via email, in the best case, to give you and provide you with a sufficient answer. We hope you enjoyed the webinar. We hope that you could learn something and that you can take something back for you and your job. And with that, once again, thank you for your participation, for your interest, and we hope to see you again in the future. Thank you very much. Goodbye.
Thank you.
Thank you very much.
Thank you.